This is the radius vector, r you take it. And how the omega will be directed out of the plane about an axis passing through center perpendicular to plane. So here I'll show the direction of omega. So let me take the coordinate axis. This will be x, this will be y for our convenience so that we can define I cap, j cap, k cap like this. Now, what is dr by dt? So as the particle rotates in circular path, so what will happen to that position vector? The position vector is going to vary. So let me define, this is r bar. The position vector is going to vary. Let me take all arrows. It'll be better. Look at this. So it's going to rotate like this, no? The position vector as the particle moves in circular path. Look at that r bar. R bar, is it a constant? No. R bar magnitude is constant, but its direction is varying. Agree this? So this is about the position vector. And there's a very fundamental concept. Oh, what happened? I'll put everything in order so that. Okay, let's take arrow and let's go for this velocity vector. Okay, there's a velocity vector. So as it moves, what happens? Even its magnitude will be constant, but the direction is going to change that one. So now let's get all the relationship between the quantities. Okay, now I'll bring that one. So there is a dr cap by dt. What do this quantity will be? So we know from mathematics r bar equal to r into r cap. So this r cap, I can write it as 1 by r dr by dt. What is dr by dt? Should be equal to r omega k cap. So r get cancelled, so we'll get omega k cap here. Then similarly, dv cap by dt should be equal to again the same formula, v equal to v into v cap. So this will be 1 by v dv cap by dt. So this should be equal to no
Sir,
dv cap by dt.
r omega I cap, sir. R omega minus I cap, sir.
No. Don't stick on to your basic.
dr bar by dt. Sir,
I'll,
dr bar by dt is v bar.
in the end you can analyze everything. Huh? Just what all I discussed, just you make observation. In the end, I'll come back. Huh? Okay, dv. This is like dr bar by dt, and as moving with a constant speed, so there won't be tangential acceleration. What all acceleration it will have? So it will be only centripetal acceleration. Okay, fine this one. So what I can write dr bar by dt, I'll write equal to r omega cap. This from omega k cap it will be. Okay, now similarly dv cap by dt, what it should be equal to? So sorry, it should be dv bar by dt. What is dv bar by dt? Speed remains constant. So what all it should have only it should be equal to centripetal acceleration. So that should be equal to an, and how it will be directed? Directed minus I cap, and in fact further, what is an? You can write in magnitude. It will be 1 by v omega minus I cap. So this will become. These are some basic relationship between them. What is the problem?
Sir, dr bar by dt is v bar. V bar is along y-axis, so j cap.
No, that particular r is what like is a fixed quantity due to rotation. So when this r bar comes here, R bar is a vector, is a position vector. Its length will be constant. Only its direction is going to change. Due to that direction, what happen? We'll get that angular velocity will be directed along k. Then the tangential velocity which is there, okay, that one its speed will be constant. That is going to change. Okay, due to changing direction of motion, what happen? We'll get a normal acceleration. Okay, that's what we say like a dv bar by
Sir,
dt. This one. Uh,
change of radial vector will be along the tangent plane.
no. You do one thing. Look at this. Dr cap by dt. It's a unit vector which is rotating. So when a unit vector rotates here, the angular displacement will take place. No. So what is this quantity? Should be angular velocity. That's what I'm showing here. No. So in fact, dr bar by dt is what you're going to write. You mean to say, sir, why don't you write this as vi cap? Am I right? I think that's what your question.
Vj caps.
Uh, vj cap, sir, why don't you write vj cap? So then further v, what you can write it as like a magnitude r omega, then omega j cap will come.
R omega. Yes, sir. Omega j cap.
We don't get any angular velocity which will be directed in this way. Because see, like, why do this angular velocity is there? Because of angular displacement of this position vector.
Sir, omega is the magnitude of dr cap by dt. That is not the direction of omega. A unit radial vector is not going to change along omega direction, sir. It will change
No,
along v
no.
direction.
See, like the theta, what is the direction of theta? Theta will be along z axis. Theta will
Numerically, we are getting that magnitude as omega.
no. Actually,
Sir,
theta.
numerical will get the
That is
value as
not
omega,
omega
sir,
bar,
but
sir. That is v bar.
dr by dt, both I component and j component will be this.
No, rotation of unit vector.
Both components will be there at this point.
Write in vectorial form, sir. We'll write radius vector in vectorial form and then differentiate. And the velocity vector in vectorial form and then differentiate.
See, like this particular thing, dr cap by dt, what happened will be a vector that will be directed. So you do one thing, r cap will come here. R cap will come here. So after some time, R cap will come here. Then you take the difference because we are going to take the difference of that one, no? Final minus initial. Okay, the time is anyway, it's a scalar quantity. Then what you mean to say somewhere it will be somewhere here, sir, because after R bar will come here. Then final minus initial if you take it, no. So now what will happen? The theta, what will come here? What is the direction of theta? Theta should be along z axis, no?
But dr bar by dt is v bar, sir, not omega bar.
No, here, say, I think we have to go back to the vectors. I think why you have one problem. If the unit vector rotates here like this, so then what we write, there's the final, there's the initial. So then it will be how it will be directed. So this will be, I'll write R2 bar, R1 bar. In fact, R1 equal to R2. So I wanted R2 bar minus R1 bar. That is delta R bar. So this will be R1, R2 for R2 bar minus R1 bar is needed. So minus R1 bar. Okay, look at this one now. So minus R1 bar, this R2 bar. So the resultant will come somewhere here like this. So that is what delta R bar. This delta R bar is what will be responsible for that small arc length. And what is delta R by delta T? That should be equal to V, no, again.
Yes, sir. Then v is not perpendicular to the plane. V is inside the plane only. So it will have I
Yeah,
cap
yes,
and j cap components.
it's one. Actually, what will happen? This delta R further, what you're going to write it as, there's a length here. This arc length. This S equal to, you're going to write R theta. This is going to vary now. d theta by dt. R is constant. This d theta by dt is what will become omega.
Sir, we are doing in vectors, so we can't write
Yeah,
like
yeah.
that.
That is what the final equation will end up like this. If you think, because this inward action, this d theta by dt will measure, you'll measure along z axis. So therefore, I should bring the k cap here. This is what the kinematics of circular motion is what brought here. The only thing is what happened, we have got stuck somewhere to relate it to this one only. This delta, okay, I'll agree, very fine. What is this arc length? What is arc length equal to radius into angular displacement? How you measure angular displacement? Perpendicular to that. From there, the direction for omega will come. This is a basic concept. Okay, we are stopping here only. What we wanted, we just wanted to, okay, stop here only, sir. No, what I'm doing further, this arc length, I'll write r theta. Theta is varying. In what direction that d theta will be directed? D theta will be directed along positive z axis, and that will give the direction for omega. Okay, there's a basic concept of circular motion. Okay, then you take the magnitude is asking. Okay, let's get into the problem. Okay, this will be under root of dr cap by dt omega k cap minus omega I cap. How much you'll get? Omega square,
Omega.
omega will get it under root of this one. Okay, this will be 1. That angular displacement will be directed perpendicular to plane of paper. That is a major concept. The angle, see, in geometry, we just say angle. The theta will show in the plane of that, but the direction of theta in what? It will be perpendicular to plane of paper. That is a basic idea, no? From there, the direction of omega will get into picture. Okay, no, so let's, it's, I think, so first time I'll project with a speed u1. So then how the path of particle, the bob will go like this. So here it is going to leave circular path. When it is leaving circular path, it will have some velocity v. This, I think most of you are familiar with the questions of these kind. Let's take this one. So what is the condition given? After leaving circular path, it has to pass through the projectile motion and it should come like this. What should be the speed u1? I think you know most of the basic ideas. So if I take this is theta, this will be theta, this will be theta. So this length is L. So what is the length it should cover? L cos theta. This will be L sin theta. Then applying when it leaves circular path. So what is the condition? Tension should be 0. I think we all know that one. The string what happened will be loose. So then for it to what happened to pass through point 2, we have directly, I think I asked you to memorize that formula also. Second situation, what is telling? I'll write down all the equations. You solve it. Already we have discussed in class. Mu1 square should be equal to mgl plus mgl sine theta plus mv square by 2. Condition to leave circular path, who will provide required centripetal force? Mg sine theta. Or select it. Tension will become 0, then mg sine theta equal to mv square L. So like this, we can replace that theta and we'll get expression for V. From how to u1 is unknown, no? What to do? You bring the idea of projectile. So what is the time? Minus L sine theta is equal to V cos theta t minus gt square. Then what is the horizontal range? L cos theta should be equal to V sin theta into t. Solving these two, we'll get expression for V. That V I'll substitute here. Okay, I get this. I'll get the theta. This theta also get theta and V I'll substitute here. I'll get the U1. I think I discussed this particular concept in class. You have this particular thing also. You know that answer also. Next part of the problem. I'll project so that it should pass through what? The point of projection. This should be the trajectory. It can happen. We have discussed it can happen also this one. It can pass through this also. Okay, let's see what mathematics you can apply.
So he didn't mention that it leaves the circular trajectory in second case.
Both the cases, no? So that it is given for it to pass through point of
Complete circular motion is also possible now, sir, to pass through the point of projection.
after leaving circular path. Given, no? Second, it is given so that it passes through point of projection after leaving circular path. Okay, it should be mentioned. Projection.
Without leaving circular path, how can it pass through point of projection, sir?
I may give some velocity where it will complete circular path.
Okay, sir.
Okay, we'll make it. Yeah, I'll add it. Huh? So that will be easy for us. Huh? Please do remember. So definitely they want to test with some small ideas. Huh? Nothing big that one. Only thing is we must know all the what are the types of formulas what we can do. And the second situation, I don't draw the diagram. It is possible, practically it is possible for it to leave circular path and can pass through point of projection also. Of course, we don't have any much numericals in our books, but practically possible. No, you just be careful, huh? Such conditions can be asked. Okay, after leaving circular path, somewhere it will come here. So the trajectory should be like this. So then again, all the same set of projectile conditions is what we are going to apply it. So here when it's leaving circular path, it will have velocity v like this. So let it be same thing, L sine theta. This is L cos theta. This is L. So this is theta. This will be theta. Only the difference is writing that equations is what? These equations, I'll continue as it is. There won't be any problem with these equations. Try to make comparison. Now, what will be the difference will be only in this equation, we are going to change it. This also let me move. So it will be minus of L plus L sine theta. Is it okay? Okay, this time of flight will be different. So let me call T2. This time of flight, let it be T1. Theta, we don't know what can be theta. Yes, this theta may be different. Yes, let it be that one. Don't bring this value here. So if you want to write it here alpha. So that will be easy for you to do comparison. Vertical circular motion, just small ideas are there. Very important topic, especially for JEE Advance. Okay, you have to calculate that ratio U2. U2 by U1 is asking. If your time permits, you calculate. Otherwise, just leave it. In exam, you must solve. There's no other way. You do have all conditions. Can it pass through this particular point? Okay, point of projection, okay, we are able to tell, and the point of projection and point of suspension. Can it pass through this particular point? See, in exam, if it gives, okay, well, good, you can directly take it. But instead of testing what happened, instead of for any speed, can it pass through this particular point? It has to describe path like this. It has to describe a path like this. So for that, what is the requirement? This range, and it cannot ascend height more than this, because it has to leave circular path, means it cannot reach this particular point. So the trajectory has to be like this. For that, what you have to check it now, you go back to some formula, no, like a what speed I should project so that it should pass through one specific point. Uh, Find the minimum speed with which a particle should be projected so that it can pass through a given point. So this is the point of projection. You know this y coordinate L sine alpha. The x coordinate will be L cos alpha plus L. Check it now. So what is will it satisfy that particular speed? First, you calculate the speed required for it to pass through here. Okay, no, that particular speed for it to happen. So if you provide, can the bob can have that much of speed here? Like this, you have to verify it. We don't have anywhere in the books discussion, but as we can do it. We have to go back to projectile motion idea, or else what happen? You have to solve it. If you get this more than root 5 GL, the problem is not possible. If it is less than root 2 GL, then not possible. Like this, we can cross verify. Okay, I'll jump to the next problem. This is about the some infinite pulleys. Okay, we'll keep this much here. Okay, on this side, like this, I'll keep on add pulleys. I'll keep on add pulleys and the blocks like that. It'll be infinite. I'm asking what is the acceleration of blocking. Let me have water. Just think on this. Okay, how to manage questions of these kind? I don't think so. In advance, can be asked. Either you do mathematically or you do by any other approach. Will be very lengthy. That's what I feel. Will be really very lengthy. As a teacher, I will not, I don't want to ask. Definitely, I can say that. What about you, sir? Will you ask? Definitely, say I will not ask. But you check our advanced paper. We can questions of these kind of outcomes. Okay, some methodology. Okay, we'll try to develop. Okay, first I need more pulleys. Yeah. I will replace. I actually it's a infinite, and I'll write down that also. This is the infinity. Yeah? Here infinity will come. First of all of you got this one like this, like an infinite ladder. How we had like this, we'll get a system. Then let me go for replacing this part. And let me formulate like this here. Let this be, let me call this as x and this particular one m dash. The mass of that effective mass of that system is x. The effective mass of this is m dash. Then further I replace this, find the acceleration of block. This will be m dash. Are able to see this? What is m dash? The red color one. The whole, there's everything. I'll replace with an equivalent mass m dash. I'll bring it here. For this m double, this one, I'll replace. Same that infinite ladder, how we had approach now, the same approach we are going to develop here. M double dash. That m double dash value is what I should find out. Then I can get the acceleration of blocking. Find the acceleration of blocking. Let's get into. Okay, I'll start with there's a theoretical background. There's a question that is it. So what is the approach? First, I'll find out the value of x, then m dash. Then you see that m dash, I know it. Then m dash will be added to this part. Then these two I'll replace with an equivalent m double dash. Once if I know m double dash in terms of m, I'll get the acceleration of blocking. Okay, now background concept will proceed like this. What we should know, background concept. So suppose that let's say that there are two blocks are there of different masses, m1 and m2. Let this accelerate up, this accelerate down. There's a tension T. How much of tension here will be? Say T dash. So what is the acceleration? This should be equal to m2g minus m1g by m1 plus m2. I think if I solve, I'll get the tension to, if I'm correct, this Pulley block system, 2 m1 m2 or 4. I think it will be 2 only. This will be, I think we know how to calculate this tension. M2g minus T equal to M2a, T minus M1g equal to M1a. Both will have same acceleration. Solving, I'll get the tension. What is T dash? T dash will be equal to 2T, and this is equal to now what should be the mass of the, can I replace these two moving blocks with a block so that the same tension can be provided in this particular string? There's a string. What should be the equivalent mass of that particular system? That I'll let me call m naught, so that the same tension I'll get it. So what is m naught? I should call m naught is equivalent of m1 m2 when they are moving like this. I'll make it here. So therefore, what shall we write here? So this m naught should be equal to 4 m1 m2 by m1 plus m2. This, let me write in better form, 1 by m1 plus 1 by m2, because that infinity is what I should take care, no? So let me put it mathematically like this. So what is the equivalent of these two moving masses? It should be equal to m naught equal to 4 by 1 plus 1 by m1 plus 1 by m2. Is it okay? So now shall we replace m dash? What is m dash? Equivalent of this moving blocks, because all the blocks will be moving. So what is this equivalent of this entire system? M dash should be equal to 4 by 1 by m plus 1 by x. I'll write it now. So what is m dash is equal to? I think I can't minimize this. Yeah. I'll try to see this one. So what is m dash? M dash is equal to 4 by 1 by m plus 1 by x. What is m dash? I think already indicate that the effective mass of that particular moving system. So this should be equal to 4mx by m plus x. So I'll take m also common, or let me write it. So this will become further equal to 4x by 1 plus x by m. Now what is m dash I should call? Anybody, can you define m dash mathematically? Is the effective mass of n to n minus 1 pulley. This is the fixed pulley. Here, there's a movable pulley. From n to n minus 1 pulley, the effective mass. Is it okay now? So what is m dash I should call? Like I'll start counting the, don't count this pulley. This is a fixed pulley. All these are mobile pulleys. I'll start counting the pulleys. So what is the m dash? Effective mass from the nth to n minus 1 pulley here. Let me define what is m dash. Effective mass n to n minus 1 pulleys. Not mass of pulleys. Again, overall, I'm just expressing that particular diagram here now. Okay, now what is m double dash? So can I replace now? Okay, m dash I got value. So now can we replace m double dash? So what is m double dash here? So this part is what? M double dash. I'll shade it now. What is m double dash? According to the same formula, m double dash should be equal to 4 by 1 by m plus 1 by m dash. So this should be equal to 1 by m dash should be equal to this should be 1 by m dash we have to write it, no? So therefore this will become 1 plus x by m by 4x. Is it, shall we write like this? Or 1 by 4x so this will become 4 by 1 by m 1 plus x by m by 4x. Let me simplify. How much will get it? 16x by 4x by m plus 1. Just check once equation. Just check the calculation. If I'm right, I'll proceed further. Okay, this will become 16x by 1 plus 5x by m. Any Can we generalize this? Anybody? Anything can we simplify? That 16 and 5 we can replace 4 square. Okay, this will be 4n x by 1 plus 5 is needed, no? So 5 will be 15 by 3. Okay, 4n minus 1 x by 3m. Because there are n number of pulleys are there, no? So therefore I just took up like this here. So the n number of pulleys are there, we'll generalize for n. Now what is n? N tends to infinity. Okay, let as n tends to infinity. So therefore this will become n tends to infinity. Anybody value m double dash. Anybody just simplify
3m.
n, huh? 3m, huh?
3m.
Okay, 3m I got it. Okay, I got now m double dash value. Huh? Let's see that where will substitute. Yeah. So in this particular system, okay, now calculate acceleration. This will be 3mg minus mg by 3m plus m g by 2. Any other you have approach, you can go for it. You can use even the some books that given mathematical method. Huh? That'll be very lengthy. Nobody will ask in advance or means, I'm very sure, but it came in weekend exam once. I don't think so. You have a time to think so much. Huh? Any Olympiad, okay. But within 2-3 minutes, cracking this much not possible. Even teacher also, nobody can think, no, how much you can. Okay, just have an idea like that. Infinite wedges, infinite pulleys, infinite springs, infinite ladder network we have seen in current electricity, can happen here also. Okay, let's take this one. Okay, now some spring cutting. We'll discuss few problems related to this. Let me draw the diagram. I think I need diagram. So this is the spring. And here is what? We'll suspend a block. It's very simple. Maybe we find a little bit very lengthy diagram all. This is the string which is going to cut this one. Let me. Which is under discussion, no? So the different strings will give different color, so that it will be easy for us, like a what will happen to them. First, initially get all the forces acting. So let's concentrate on the first diagram. It'll be easy for us. First, we'll get it. So let the tension here be T. This is mg. The tension will act here. So the tension in this string, let it be T1. Here T1. Uh, 2m. I'll change it. It is 2m. Let me put all masses 2m, m, capital M. Yeah, fine. This force will be 2mg, and let this tension, this string be T2. This will be little bit, I think in exams, you have to be extra alert. That's all. Questions can be solved in limited time. Only thing is we should be extra alert with more strings are there, spring and springs are there. Extra alert we have to be. Kx naught, this mg. What are equations we can write it? We'll write all the things. So let me call this as block A, block B. Let me give number naming, so that will be easy for us. So let's write equation. Initially at equilibrium, or first diagram. So in the first diagram, on the block D, T minus mg equal to 0, or directly write tension, because we need values, no? So T equal to mg. Then on A will be T1 equal to 2 small mg plus T2. Then on C, T1 is equal to Kx naught plus mg. On D, Kx naught is equal to T2 plus mg. Okay, these are the equations. What is T? T is equal to T1. Looking at that pulley here, this particular pulley, this tension should be equal to T1. Let me substitute this. T is equal to mg, capital mg, and T1 Kx naught plus mg. On block C, from there I'll write it. Okay, there's one major equation. Further, Kx naught, what you can write? Kx naught equal to T2 plus mg. Solving all that 4 equations, so we'll finally will end up this T2 plus mg plus mg. Whether it is useful or not, we'll see. Okay, at equilibrium now, I do have the tension T2 value, T1 value. Okay, there's the initial part. Whether it's useful or not, I too don't know. Just I wrote it. Okay, these are the. Can we find out tension in all the strings? S. Okay, now what is T2 equal? T2 equal to a capital mg by 2 minus 2 mg. After getting T2, I'll substitute here. Then I'll get T. So like T1 is what? T by 2. In that way, we can express all the quantities. Now I'm going to cut this particular string P is going to be this cord is going to get cut. What will happen to the okay, this is will show like this. I'm just showing it. Immediately is asking what should be the range of mass m so that acceleration of the load of mass 2m becomes greater than acceleration of free fall. So what is our point of discussion? Immediately we have to jump to the block A and B. Acceleration of load of mass 2m means is okay, this is 2m. Its acceleration should be more than g. The load is asking. So what will happen to spring force? Will it change? The primary idea we have to start from here. Will spring force will change? Sudden change in spring force not possible. So I'll put the same spring force kx naught. This will be mg. What will be the tension? The tension will have some other value. Let me call T. And here the weight 2 mg. Now look at this. Spring force will not change. Kx naught. So this will be mg. What will happen to this particular block D? Definitely it will try to move. I may ask you further anything about the blocks A, B, C, D all. So what about the D must move down? What about C? C must move down. How to bring that mathematical conditions? What he has put in. Simply telling the acceleration of load of mass 2m becomes greater than acceleration of free fall. Himself he has given that condition. So therefore, the block A must have acceleration, and that should be how much it should be. It should be greater than the acceleration of free fall. So let me put that acceleration, let it be A. So now they're connected by a common string. If this is having acceleration, string is inextensible. So it must have acceleration A like this. So who is responsible now? The spring force only. So altogether, this kx naught, how much of the tension will become internal? So this kx naught should be greater than 3 mg. Shall I write it here? Sir, now you can ask questions, sir. Why not tension? Well, tension will be same T2 or some other value. We don't know that. You just ask some mathematical conditions here. So therefore, for acceleration of blocks, the initial, yeah, for block A to have acceleration A greater than G. So what is the basic necessity condition? Kx naught should be greater than 3 mg. From where I'm bringing, say like here tension T is acting. That will become internal to system. Then 2 mg and mg is there. So kx naught should be greater than 3 mg. So how do you can write kx naught minus mg minus t equal to ma, 2 mg plus t equal to 2 ma. So that A should be greater than for acceleration to be greater than G. So therefore, so we'll write this condition. Shall I write directly or individual if you want? For individual block, you write it. Finally, you'll end up with the same condition. Okay, this kx naught value will not change. How much it was equal to T2. How to introduce from here further after this, what to do. relation between capital M, small m is how to introduce capital M. So Kx naught shall we write T2 plus mg, like initial value what we know. Okay, I have some things, so I'll write T2 plus mg should be greater than this one. So T2 should be greater than 2 mg. Shall I take help of this last equation? I'll write it equations. We'll do one thing. These are the primary equation 2, 3. Put 1 in 3. Okay, I'll end up 4. Now put 2 in 4. T2, what we can write it as? Capital Mg by 2. Anybody value of T2? Okay, I'll write one more step. It'll be easier.
Sir, how did you write kx naught greater than 3 mg? If we solve, we'll get kx naught greater than 2 mg.
Cannot happen, huh?
Kx naught plus 2 mg minus mg by 3m must be greater than g. That is what you mean by that equation.
Write down the equation. Huh? Kx naught minus T minus mg equal to say some me. 2 mg plus T should be equal to 2 me. Kx naught plus 3 mg equal to 3 me. So what is the basic necessity for acceleration? Should be greater than g, it should be
Not plus
required.
mg, sir. Kx naught plus mg equal to 3 m. Addition wrongs.
Kx naught plus mg, no? This is
A greater than g, so kx naught greater than 2 mg.
A should be greater than mg. Not 3 mg will not come. Okay, let's see. Kx naught should be. I'll write it. Kx naught equal to 3 ma minus mg. So A should be greater than g. Greater than or equal will make it. So at the most development, Kx naught will be greater than 2 mg will get it. Huh? Okay, I'll put it 2 mg. Then we'll get only mg. Okay, the value of T2. T2, what we can write? Mg, capital Mg.
Capital M greater than 6.
I'll write it. This will be capital M minus 4 mg by 2 greater than mg. So this will be mg minus 4 mg greater than 2 mg. 6 m. Yeah. So here I'll put it this condition as A must be greater than G. So therefore Kx naught at least what happened should be 2m. I thought I was adding marks also.
Sir,
Mm-hmm.
to write tension in the left side and right side is equal, we need to ensure that the string is taut. How are we ensuring that?
Which one? Which one? Green color stringer.
Yes, sir. Second diagram, green color string. We are writing tension same on both sides. That is possible only when the string is taut. So how are we ensuring that?
No, that's what the question is defined. No, the question himself he has defined. For it to be acceleration greater than G, tension should be non-zero.
Okay, sir. Understood.
So the question is defined. That's why I assumed it. So I that's why I started. Otherwise, I would have made another thing. Himself has put a condition. It should be tau. Then only possible, no? So therefore, he has put a condition like this, I'm assuming. Otherwise, definitely I would have questioned myself also. Hmm? So I think we have to just stick on to the small equations and keen observation we have to make it, especially this spring, string, cut. Even for me, teacher also, when I should minutely make observation, I should come by order. There's no other way. No guesswork anywhere. I think there's a very popular, and check the advanced paper. We don't have any question till date like this. String cut, spring cut. We don't have even till date, no questions is available in the advanced question. They never ask it till date. So whether they may ask, may not ask, we don't know. Because practically what happened, all these are ideal, because practically we'll never get a string which is massless. Pulley will have a mass. So maybe IT professors may feel, okay, these are all insignificant, all that one. So that's why they might have not stressed it. What we are discussing is the ideal. Practically, if I go and take no, string will have a mass, the spring will have a mass, so many pulley will have a friction. So can be a surprise for you. Possibility is there. Okay, I'll take this one. One more is in about one question. Some circular motion. Simple. Some conical pendulum is mixing with the friction concept. Now there's a level what you can definitely anybody can do such problems. I don't think so any difficulty there. You can see that just you have to make good observation of the situations available. So here mg will act, the tension P. Recollect conical pendulum idea, it'll be much easier. Mass of the block shows a block of mass in mg, normal contact. So definitely the friction must act in this direction. What are other forces? Yeah, this much is there. No, for it to be in circular path, he has given omega, circumference of radius r equal to 50 centimeter. Okay, even we have this radius. First, we'll get into conical pendulum ideas. This one, T cos alpha minus mg equal to 0. T sin alpha will provide required centripetal force. T sin alpha equal to m omega square r. And then T sin alpha on the block n minus mg equal to 0. T cos alpha equal to f equal to mu n. Determine the lowest friction coefficient mu between the box and the table that prevents the box from sliding. So let me get into this T cos alpha equal to f equal to mu n. So T cos alpha equal to f. So let me substitute all this one. What is T is equal to? T cos alpha should be equal to mg. And what is f? F should be equal to mu n. Small mg, it is. And there are two m's are there. T sin alpha plus n minus m. Small m, capital m's are there. Just be alert. Small m mu equal to. So what is further n you can replace mg minus T sin alpha. So small mg equal to mu, capital mg. T sin alpha, we can write it as m omega square r sine alpha. We don't know alpha, so dividing these two equations, so tan alpha is equal to tan alpha is equal to alpha is given, not there, yeah. How to eliminate alpha?
Divide first two equations.
From there, tan alpha, I think we know all the values here. Tan alpha equal to omega square r by g. We know omega, we know r, will g, will get tan alpha. From that, I'll get sine alpha. Then I'll proceed here. Then I'll get expression for mu.
Sir, you took mu n is equal to mg, sir. How did you take like that?
Which one? Mu n. Huh? Mu n equal to the
Okay, sir.
norm.
Okay, sir.
Yeah. Mg minus t sine alpha it is. Mg minus small m. Okay, now what is asking, sir? Lowest friction coefficient. Why that lowest is brought here? Word? Anything we have to further think, or this is sufficient?
Static friction, no, sir. So
Anybody wants to interpret? Oh, answer one. Na? Mu is one. Na?
yes,
Okay.
sir.
Sir,
Yeah.
you substituted wrong, sir. Mg equal to mu into capital Mg minus m omega square r only, sir. Again, you wrote sine alpha. T sine alpha is only m omega square r, no, sir.
Oh, once again I wrote sine alpha will not be there. T sine alpha. Okay, fine. Yeah. If the value of this, if the value becomes less than this, then open equilibrium not possible. Anything greater than this, as equilibrium will be possible. Then the static friction will come. The value becomes more than this, then definitely the friction will not be sufficient to overcome T cos alpha. Then equilibrium is not possible. This is the lowest value is what he's asking. Anything greater than this, okay, fine. Equilibrium is possible. Intentionally brought mu. Mu, what happened for most of the objects around us, what happened? Will be less than 1. But the situation like this, what happened, needs where mu is should be greater than 1, greater than or equal to 1. So definitely I should take care about this particular thing. That's what the question actually. The question is not to test any of our basics. Practically, a situation may arise, but most of the objects around us, the mu will be less than 1. Between any pair of surfaces, mu will be less than 1. So definitely what happen, if I just keep that object not possible. So therefore, I should take care about this surface is what you mean to say. That's what the problem actually. If you look at the application part. For us, it's just mere mathematics, writing equations and solving. Let's go for one wedge constraints. This is some very good problem. We can manage. So I think by this time, everyone is quite aware if a block sliding on a wedge and what to do. Yesterday also we discussed some 2-3 problems. No, by this time I think you might have developed a basic idea. So first in wedge constraints, what is the biggest headache for you? In what possible directions they can move? Okay, first I'll release the system from this. So mg sine theta, tension T, normal contact, mg cos theta, normal contact here. These two actually should be parallel. This is t. Show like this. This is t. Now, what is the possible? This is about the natural way in which they are available. In what possible direction they can move. The moment I release, how do the block B will move? How the wedge A will move? There's a decision a student has to make. There's no other way. Looking at the forces available. In what possible direction the wedge will move? You look at this T cos theta. Here N1 sin theta is there. Okay, fine. So this should move towards right. So let me take this acceleration. In what possible direction this wedge B will move? It must be towards left, no? Because the tension is there here. What about the block? What direction it should move? In a ground frame, very difficult to solve. Better go for wedge frame. So it should slide down. So the acceleration, they should be AR, you call it. Acceleration of this, let it be AR. Then as we are describing motion with respect to different set pseudo force will also come. MAE. Then motion of the block perpendicular to incline along the incline. We have to write equation. I think you see that as this moves open, this particular string will make inclination. But the question is asked when the system is raised from rest. Okay, assuming that this will remain vertical, we are doing the problem. This will be very confusion for everyone in the exam. I too thought, okay, it will take some angle, then how conditions will come. But yeah, made that when the system is raised from rest. Okay, the string will remain vertical only. Okay, writing all the equations. T equal to mass of the block, MB, A and B are 4M, no? So directly let me write it, 4M AB. T plus N1 sine theta minus T cos theta should be equal to 4M into E. Then mg sine theta plus MA cos theta minus T equal to M into AR. Then perpendicular to incline, N1 component of pseudo force. What is this one? Component of pseudo force. Its component will be MAA sine theta. Its another component will act along the incline, MAA cos theta. And AR is the acceleration of the block related to this one. How many unknowns are there? T, N1, AB, AA, AR. I think we have 5 unknowns are there, 4 equations are there. What is the next only thing? So how the displacement of wedge and the block are related to change in length of string is what we are to do. This length will not change. There will be change in length of this string and this string. What is this length correspond for? Change in length. Displacement of block with respect to wedge. Okay, the change in length of this is what equal displacement of block with respect to wedge. Change in length of this is what? The sum of displacement of this. So what is the constraint equation? It will be XR and this will be XAB. So if you write equation, it should be AR should be equal to, now why it should be positive? Because they're having displacement in opposite direction. Or you want to come from the beginning, overall length of the string will remain same. XA minus of minus XB, you write it. Or you do one thing. So this will increase. Okay, later on, I think it will be. And now we'll differentiate 0 dxr by dt, the double differentiation of that, and it will be, okay, to bring sign also, no? This will try to increase, this will decrease. Okay, it should be like this. No? This will try to decrease the length, minus AE. Due to XB, it will be decreasing. No? So decreasing again, positive or positive. So AR equal to AA plus AB. If you, I think this in exam really troublesome. Directly like the decrease in length of this is equal, the increase in length of this is equal to decrease in length of this string. The length of this string is decreasing because both are moving towards each other, and you can make it. Solving this two will get the required answer. No need to solve, just have an idea, because I want you to just like it, this particular thing is very important, because we have done most of the problem. This was fixed here. Now even this can also be movable. This constraint equation, go for change in length. Don't go for mathematics like this. So this will be very troublesome. Increase in length of this is equal to decrease in length. Why this length decreases? Both will move towards each other. So therefore, you should add up. And this is a simple problem based on block upon a block. Only strings I brought it. Let's have like this. So first it's talking about the equilibrium. Let's proceed here. What about the mass of this? Mg. The tension, let it be at T. Since the same string, no, so the tension will be same. So this is T, this is T. Find the maximum value of M so that system does not move. How to manage this particular thing? So definitely the friction here should be maximum F2L. Mu1, mu2 is given F2L. So why the friction I should take here? Because you look at the tension here. Will be acting, so it will, this tension, the rope will try to pull the block 3 kg towards right, and because of that the limiting friction should act here. Now what about the friction here for the equilibrium? We'll do one thing, we'll write first F1, F2 like this. No. Is it okay getting the direction of frictions? So treat this 2 kg as one block. So what is the role of this friction? Will become like internal, no? So therefore, when for maximum value of M for equilibrium, what happen here? The limiting friction will come. When M becomes maximum, this will become F2. So let's write the equation first. This will be T should be equal to F2. Oh, combined block. So that F1 will become internal, will get eliminated. And this 2T further should be equal to Mg. So therefore, Mg should be equal to F2. So when M becomes maximum, this F2 will become limiting. So the maximum value of this will be F2L by G. This should be equal to mu2, 2 plus 3, 5 mu2. Okay, there's a maximum permitted value. Okay, after getting this one, mu2 value how much given? 0.5, 2.5 kg. Now he's asking what will be that F1 when it is this much here. I think definitely we can calculate 2t equal to mg. Then we'll calculate the F1 equal to t. So I'll proceed after this. F1 25. So t equal to 12.5 Newton. Then F1 equal to t. Okay, what is a t? 12.5. But what is the maximum permitted value of F1L? I think we need first. F1L will be anybody value 15 Newton. F2L 2, 3, 5, 25. Okay, you see this one. What is the nature of friction that is acting? Still, it is less than F1L. Will be static. Okay, there's the initial first part of the problem. Okay, now come forward. If m equal to 4 kg, so how much it is the maximum permitted value for equilibrium for no slipping? Find maximum value of m so that the system does not move. There'll be a test. That's what we discussed here. Now instead of 2.5 kg, I'll make it 4 kg. Find the tension the string attached to 2 kg block. Is asking what will be the tension, or is asking tension the string. Okay, second part of the problem. What is the situation? So will they will move together, or still it will be at rest? I think any of the cases can happen. Okay, I'll go for second part of the problem. Second part of the problem, it will be definitely the block will accelerate. So mg minus 2t should be equal to m. M is given how much? 4 kg. Yeah? So this will be 40 minus 2t is equal to 4a. Keep this equation in the hand. Then together, I'll assume that I'll show a small diagram so that it will be easy for you. Here tension T and T. I'll assume that here limiting friction will act F2L and here a static friction and will act here, and let there have a common exertion E. So then the solving this one will be 2T minus F2L is equal to 2 plus 3 into E. Let me solve this. I'll calculate the tension. Anybody value T and E? First, let me add up this. Anybody value A? 2T, 4G minus 2T, no? So this will be 40 minus 25, 15, 15. Okay, 3 Newton. Oh, 4A, no? 5A, 9A. 9A will be 40 by 9A. 40 by 9. 40 minus 15, 15 by 9. 15 by 9A or 15 by 9. Okay, 5 by 3. Yeah. Anybody value T? How much tension? $25 by 3, 25 by 3, 25. 50 by 3. Okay, let's check now. I'll write equations of motion on the block 1. So T minus F1 equal to 2A. T value I know, 50 by 3. F1, this will be 2 into 5 by 3. 50 minus 10 by 3, 40 by 3. 40 by 3 will be 13.33 Newton. I think still less than F1L. No? So what will happen? What I assumed is right or wrong? No slipping occurs is what I assumed. In fact, correct, no? Condition assumed, no slipping. I got the F1 less than FL. In fact, what I assumed is wrong. Find the tension attached to the block. So what all I solved it, it's correct. So this is very important. A friction, this is what actually students see. Don't assume that no slipping and do the problem and you get answer, okay, sir, this is what happens. So first, no slipping occurs. Check it, no slipping occurs or not. So how to check it? Calculate the static friction, calculate the friction acting between 2 kg and 3 kg block. If it is less than F1L, then what we assumed is correct. Assumed condition is correct. Condition assumed is let me write clearly. Condition assumed is no slipping occurs between blocks. Fine. Put it like this. Okay, then you do it. So some students, I don't know what will happen to you in exam. They'll assume that slipping occurs and they do it. They'll get one value of tension and there'll be one option related to that value also, and you'll pick up, it'll come out. But always first go for no slipping, check it. Friction acting between block less than limiting, then what you assumed is right. F1 is greater than F1L, then slipping occurs, then you carry on problem. Just you wanted to test students that will they think like this. I think there's a one where whenever friction comes between the blocks, no, I think there's a one natural way of analyzing here. Okay, similarly, can you work out other options, third and fourth, you try to solve or leave it. There's a thing. What is the time? Yeah. And there's one small one. Okay, we'll finish off this. Huh? Carefully look at the conditions that are some routine earlier what we did. So something like pendulum, you'll go and collide with a bob. So, but here you see that one, it is not, the pendulum will come and strike it. The pendulum, in fact, it is in contact. M1, M2, let me write it. Not road. Now look at the question carefully. Find the acceleration of block B immediately after it is released. So there's a string of length L. What are the various forces that are acting? M2G. Normal contact N1, here N1, M1G. Tension in this is a light stringer, as mentioned. So there's a floor which is, so what are the possible ways in which block can move? The block must move like this, no? What about the block M1? It's very simple. We may think that, okay, fine, but there's all possibility of going wrong. Anybody. There's all possibility of definitely going wrong. We have to look at the constraint equation very clearly. So here, will it immediately lose contact? You see that the block, what happened? The moment I release, it will start pushing it. No, they will be in contact. So acceleration along common normal must be equal. Then what is the motion of block? How do block what is having a tendency to swing? No, it is, and the block is having only tendency to slide on the floor. Therefore, if I look at only the motion of the block, it will be this M1. So here is what? Okay, this is theta. The block is going to have acceleration like this. And sorry, the block and the wedge, what happened, will have, in fact, they're in contact. To show things clearly, I just made it in this way. So this is what the motion of the block, it will have acceleration in this direction. Okay, let's write what is the condition. We can write it, constraint equation. Acceleration along common normal must be equal. This, you extend this line so that it will be easier. This you write common normal. Acceleration along common normal must be equal as N1 will be greater than 0. That's the only reason. They will be in contact. The block will not lose contact. It will be pushing it. Immediately after it is released. So they'll be in contact. We are not doing problem after some time. I think this condition, if you can get it, it'll be also big because of that. Okay, let's tell you right equation. So we will make block to accelerate. N1 equal to M2 E2. Whatever the motion of this, and this will be perpendicular. This will be perpendicular. So here N1 will be acting in this direction. Okay, let's write equation. M1G it is. Theta, what theta? Theta will be here. Now M1G sine theta minus N1 cos theta will come up. Yeah, N1 cos theta should be equal to M1 even. Sir, why only I should think like this? Because we know just like a pendulum, no? Sir, why can't it have acceleration any other way? Anybody?
Inextensible coordinates.
The string
Can
is
only be tangential.
yeah, the string is inextensible, and also it must be taut. So this is the very important part. If even your teacher also, if he just write this equation and complete the problem, maybe he don't know anything. Just somehow he knows he brought equation and he finished the problem. The teacher is not having any concept. Just he knows mathematics, no physics. So what is it? This called strictly taut. This is a very important idea of the problem. From here is what all the discussion should start. Say like a taut it should be. So tension must be non-zero. That's the one thing. Then inextensible. There cannot be any acceleration in this direction or any other way. The acceleration of the block should be perpendicular to the string. Then only it can be inextensible. Okay, the constraint equations, be careful. So that's what anywhere you can introduce. Okay, we'll stop class here. I think you're having a 2 o'clock exam. Do revise. After exam, I will meet for paper discussion. Okay, recollect formulas and go. What all you feel formulas which you find very difficult, no, you recollect them. Okay, thank you.